Hey guys, welcome to your first lesson in CPM 2. This is Module 1, Lesson 1. Please feel free to rewind and pause this video as you need. The good thing about these videos is that these are at your own speed. So if I go too fast on something, you can rewind it, watch it as many times as you need. You can pause it so you can write down your notes, process it, whatever you need to do. First lesson here is over section 1.7. And it's over exponents in order of operation. So objective A is to write repeated factors using exponential notation. So in the product, 3 times 3 times 3 times 3 times 3. Notice that 3 is a factor several times. When this happens, we can use a shorthand notation called an exponent to write the repeated multiplication. This is called exponential notation. Okay, so using that exact example, we have 3 times 3 times 3 times 3 times 3. It says 3 is a factor 5 different times. So you've got the repeating factor of 3, and it's repeating a total of 5 times. So when that happens, we can shorthand this by writing the base as that repeated number, in this case 3, and then your exponent is going to be the small little number that goes above it. And so it says here that this, you read it as 3 to the 5th power. So the exponent 5 indicates how many times the base 3 is a factor. So you have these different expressions here and how to actually read it. So when you have this 5 as the base, 2 as the exponent, this reads either 5 to the 2nd power, or a lot of times you'll just hear it referred to as squared. So 5 squared. When you have 5 as the base and 3 as the exponent, you can read this as 5 to the 3rd power, or you will hear it often terms referred to as 5 cubed. And then when you have 5 as the base, 4 as the exponent, you'll read this as 5 to the 4th power. So you can read these all as 2nd, 3rd, 4th. That's perfectly fine. When it is a 2 as an exponent, you'll often hear it as squared, 5 squared, x squared, 3 squared. When you have something to the 3rd power, you'll often hear it to it as cubed, 5 cubed, x cubed, y cubed, 7 cubed. After you have that 3rd power, then you just use 4th, 5th, 6th, 7th, 8th power. So y to the 8th power, 3 to the 12th power. Okay, so your exponent of 2 and 3 only have those kind of special terms. So example 1, write using exponential notation. So you've got a repeating base of 7. So 7 is your big number. And how many times is 7 repeating? That's what your exponent is. So you've got 1, 2, 3. So this is 7 cubed, or 7 to the 3rd power. On B, you have 3 times 3. So what's the repeating base? That is 3. And how many times is that base repeating? This one's only 1, 2. So you either have 3 squared or 3 to the 2nd power. C, what is being repeated in this one is 6. And how many 6s do we have? 1, 2, 3, 4, 5. So this is 6 to the 5th power. Now D and E are a little bit different because now we have different bases. So we have a cluster here of 3s and then a cluster here of 9s. So if I'm looking at just these 3s first, my repeating factor is 3. How many 3s do I have? 1, 2, 3, 4. So 3 to the 4th, and then times, you've got 1, 2, 3 9s, so 9 cubed. E, we now have 3 different bases. We've got 5, we've got 7, and we've got 4. So if I use that first base of 5, we've got 5, 1, 2 times, so 5 squared, or 5 to the second power. Then we have this one lonely 7. So when you have only one of something, you can do it one of two ways. You can either say 7 to the first power, since you only have that one 7. This is technically just fine, but we usually don't write that 1 up there. And so I'm just going to write that as just 7. But if you put that to the first power, that does mean the same thing, and that is counted as correct. And then times 4. And how many 4s do we have? We've got 1, 2, 3, 4, 5, 6. So 4 to the 6th power. Now on this next page, we're going to kind of do this in opposite order. In this next page, we're going to kind of start right here and have to rewrite it with all those repeating bases so that we can come up with a number. So B, we're going to evaluate an exponential expression. We write the expression as a product and find the value of the product. So 9 squared, this means my base is 9, and this exponent tells me how many times I have that base. So in this one, you got 2. So we have 9 times 9. Keep evaluating. When it says to evaluate, what this means is that you need to get to one single number. So 9 times 9 is 81. Okay, on B, you got 3 to the 4th power. So your base is 3. And again, this 4 tells you how many 3s we have. So on this one, we've got 3 times 3 times 3 times 3. I got 4 of them since that's what my exponent is. So multiply. 3 times 3 is 9. Bring everything else down. I'm actually going to write this a little bit different, but that's the same thing we're doing. Let's do it this way. 3 times 3 is 9. So then that kind of goes away. Bring down everything else. Now we've got 9 times 3 is 27. So that goes away. Times 3. And so then 27 times 3, I'm going to bring that over here. 7 times 3 is 21, so the 1 comes down, carry the 2. 2 times 3 is 6, plus this 2 gives me 8. So my answer here is 81 again. C, you got 6 cubed. So 6 is being repeated. That exponent tells me 3 different times. So 6 times 6 times 6. So 6 times 6 is 36. Bring down your times 6 on the end. That goes away. So then 36 times 6. 6 times 6, 36. So your 6 comes down. Carry your 3. 3 times 6 is 18, plus 1, 2, 3 is going to be 21. So my final answer here is 216. 1 to the 5th power means your base is 1, and it's being repeated 5 different times. So 1 times 1 times 1 times 1 times 1. Well, it doesn't matter if I do 1 times itself 100 times. 1 times 1 is always going to be 1. So when you have 1 to any number exponent, to the 20th, to the 2000th power, it's always just going to be 1. On E, you got 11 to the 1st power. That's kind of like what we were doing on this portion right here, right? We said that we could have done that as 7 to the first, that's the same thing as just 7. So same thing here. If you have 11, that's your base. How many times is your base repeating just this one time? So 11 to the first power is just 11. So if you have anything to the first power, it's just that number. So 20 to the first is 20. 258 to the first power is 258. So if it's to the first power, it's just that number. Now on F, this little helpful hint down here is kind of explaining F to us. An exponent only applies only to its base. So for example, 4 times 2 cubed means the 4 comes over that one time, but then you have 2, 1, 2, 3 times. So same thing on this one. This 5 just kind of comes down. And now this 6 squared means my base is 6 and it's repeating 2 times. So 6 times 6. So evaluate. 5 times 6 is 30. And then 30 times 6. 0 times anything is 0. Multiply this way. 3 times 6 gives me 18. So my answer here is 180. And then this helpful hint is just to kind of be a little bit of a helpful reminder that multiplication and exponents are different things. It says don't forget that 2 to the 4th power is not 2 times 4. When you do 2 to the 4th power, that means you've got 1, 2, 3, 4 different 2's. And so when you multiply this out, 2 times 2 is 4. Bring down everything else. 4 times 2 is 8. That goes away. And 8 times 2 gets you to that 16. When you do just 4 times 2 or 2 times 4, you get 8. 8 and 16 are different numbers. So those are not going over the same things. Exponents and multiplication are different. So that's half of your lesson. The other half of your lesson are these order of operations. When you're using order of operations, there's a certain order you have to go when you're evaluating these things. So these 3 different things, this one, and this one, these are all saying the exact same thing, just in different ways. So I put the same information to you 3 different ways. Choose whichever one you like. This first one here is from the book. And it says, number 1, perform all operations within parentheses. This also gets extended to brackets and other grouping symbols such as fraction bars, starting with the innermost set. Number 2, you're going to evaluate any expression with exponents. Number 3, you're going to multiply or divide in order from left to right. And then 4, you're going to add or subtract in order from, again, left to right. So what's important about 3 and 4 is it doesn't matter if you have a division problem first, then multiplication. If this comes first in the left, you've got to divide, then multiply. So don't just think because we're saying divide or multiply or divide that that's the order we're doing that in. Okay. So, a way to help you remember versus just memorizing this information, and this is the way I was taught when I was in school, is this: please excuse my dear Aunt Sally. So that P for please also stands for parentheses. That E for excuse also stands for exponents. My dear stands for multiplication and or division. And again, that's left to right. And then Aunt Sally stands for addition and or subtraction, again from left to right. So you'll see me a lot of times kind of put this PEMDAS. This is your please excuse my dear Aunt Sally, and that stands for parentheses, exponents, multiplication, division, adding, subtraction. And then this last one here is the same thing as really this one here, but it's just way more condensed. Tells you parentheses first, exponents, multiplication, such a big thing from left to right, addition and subtraction from left to right. So let's try some. Let me get rid of all this first. Okay. So for this problem, we've got evaluate. So I'm going to put my please excuse my dear Aunt Sally. Go down the line here. Is there anything in parentheses? No. So I can skip my parentheses. Are there any exponents? No. So skip this one here. So now multiply and divide. Yes, we've got some multiplication here, so I need to multiply. So 10 times 2 gives me 20. Bring everything else down that I haven't used. Haven't used that 15, and I have that addition. So then you're going to add or subtract, and we've got something to add. So 15 plus 20 gives me 35. Okay, and remember, we're evaluating. When you evaluate, you cannot stop until you get to that one single number. So I cannot stop right here at this 15 plus 20 because we know what 15 plus 20 is. That's 35. You've got to keep going to get to one number. B, please excuse my dear Aunt Sally. So do we have anything in parentheses? No. Do I have anything with an exponent? No. So multiply and divide. We're multiplying and dividing from left to right. So notice you have multiplication first right here. So we're going to multiply before I use this division symbol. So 2 times 4 gives me 8. Now drop down everything else we haven't used. Haven't used that minus 3 and divide by 3. I still have some multiplication and division to do. So now I need to divide. 3 divided by 3 gives me 1. So drop down everything else we haven't used. 8 minus 1. Now I only have one operation left, so let's do it. 8 minus 1 gives me 7. C, please excuse my dear Aunt Sally. Do we have anything in parentheses? No. Do we have any exponents? Yes, we do this time. So you've got 4 squared. So remember, 4 is your base being repeated this many number of times. My exponent is 2. So this is 4 times 4. 4 times 4 is 16. So drop down everything else we haven't used now. Now we need divide by 2 times 4. So now multiplication and division. This is where it's so important that we have left to right. Even though it says M, then D, it does not mean you're always going to multiply before you divide. So for example, from left to right, my very most left thing here is division. So we need to divide first. So 16 divided by 2 is 8. Drop down your times 4, and now we have one operation left. So 8 times 4 is 32. On D, we've got please excuse my dear Aunt Sally. We have no parentheses. We have no exponents. So do I have anything to multiply or divide? Yeah, we only have one thing here. 28 divided by 4 is 7. So drop down everything else we haven't used. Haven't used this plus and haven't used this 10. So use your one last operation. 10 plus 7 gives me 17. On E, when I use that, please excuse my dear Aunt Sally. We usually call this P parentheses, but notice up here, this is why I use this book one that's super wordy. It's not just parentheses, it's also brackets and other groupings such as fraction bars. So on this one, for those parentheses, we need to simplify the top of this fraction before we go down to the bottom. So on the top of the fraction, you almost have to use this just for the top portion before you can go down to the bottom. So on the top, we have no parentheses. On the top, we have no exponents. But on the top, we do have some multiplication and or division. So I need to divide this right here first. So it means I've got 16 minus 12 divided by 4 is 3. And that's all over 1 to the 17th power. So now we have some subtraction. 16 minus 3 gives me 13. Okay, so now on the bottom I have an exponent. 1 to any power is just 1. So 13 over 1. And 13 divided by 1 is 13. And then for F, please excuse my dear Aunt Sally. On this one, do we have any parentheses? Yes, we do. So even though add is way down here and multiply is up here, because this is in parentheses, we've got to actually add this time before we multiply. Okay, I'm just making this worse, aren't I? Okay, sorry about that. So we've got some parentheses. So in these parentheses here, 4 plus 3 gives me 7. So then bring down your times 2, and now you have one operation left. So 7 times 2 gives me 14. All right, let's turn the page. We're actually going to get into some harder order of operations problems. And I am going to skip G, because if you notice, G is the exact same thing as what we did right here on C. So I'm going to skip G. I'll just write here, look at problem C. On H, we've got please excuse my dear Aunt Sally. Do I have any parentheses? No. Do I have any exponents? No. So multiply and divide. So remember, even though we have multiplication right here, this multiplication and division is from left to right. Oh, heck no. Sorry guys, do we have any exponents? Yes we do. We've got 8 squared. So 8 squared means your base is 8 and it's repeating twice. So 8 times 8 is 64. And now drop down everything else. Divide by 0 times 2 plus 4. Okay, that was my exponents. Sorry about that. So now let's go to multiply and divide. And again, even though multiplication is right here, this does not mean always multiply then divide. We are multiplying and dividing in order from left to right. So we've got to use this division that comes first. With this one, you cannot divide by 0. So because we cannot divide by 0, we can just kind of stop right here. This answer is undefined. And that is actually my answer. When you come across a problem where you've got some number is being divided by 0, you can't go any further. You've got to stop. Okay? When it's divided by 0, undefined. So we are done with that problem. On I, please excuse my dear Aunt Sally. Do I have any parentheses? Yes, I do. So within those parentheses, use your order of operations. In those parentheses, do we have parentheses? No. And this is what I mean by, do I have parentheses in parentheses, right? You've got grouping within grouping. So no parentheses within the parentheses. Do we have an exponent? Yes, we do. So 5 squared, that means 5 is your base and it's being repeated 2 times. So you've got 5 times 5. So that's 25. So bring down everything else we haven't used. We've got plus 7 parentheses, divide by 4 times 2 cubed. Okay, we're still not done with parentheses. So in those parentheses, now we only have an addition. So 7 plus 25 is going to be 32. So drop down everything else. All right, so now I've taken care of those parentheses there. So now exponents. Do I have any exponents? Yes, we do. So this exponent here means my base is 2 and it's repeating 3 times. So we've got 2 times 2 times 2. Well, 2 times 2 is 4. Drop down your times 2. And 4 times 2 is 8. So let's drop everything else down. Haven't used 32 divided by 4 and then the times. So now we've taken care of the exponents. So now multiply or divide, and we're doing this in order from left to right. Again, it does not always mean multiply, then divide. What comes first? So in this one, you've got division first. So 32 divided by 4 gives me 8. Drop down your times 8, and 8 times 8 is 64. Okay, J, please excuse my dear Aunt Sally. So, do we have parentheses? Yes, we do. In those parentheses, we've got 8 minus 6. So that's going to give me 2. Drop down everything else we haven't used. We haven't used this exponent of squared plus 2 cubed times 3. All right, so we have 2 different sets of exponents. So first one is 2 squared. That's 2 times 2. 2 times 2 is 4. Drop down everything else, plus 2 cubed times 3. Still not done with exponents since I have this 2 cubed. So 2 cubed means I have 2 repeating 3 times, and we actually just did this right here, right? That means you've got 2 times 2 times 2. 2 times 2 is 4. Bring down your times 2, and 4 times 2 is 8. So now drop down everything else. I need my 4 plus, and then my times 3. So those are my exponents. So now multiply and or divide. We've got multiplication problem right here. So 8 times 3 is 24. Bring down your 4 plus, and 4 plus 24 is 28. All right, on to K. K has a lot going on. I'm going to change colors just because I feel like it's going to bleed in with I or with O. So let's go purple. Okay, we've got please excuse my dear Aunt Sally. Do I have parentheses? Yes, we do. And so I'm going to go over to this last page. Oh, where'd it go? There it is. Okay. When you have parentheses, okay, in example 1, you've got to start with parentheses, brackets, or any other grouping, starting with the innermost set. So you've got brackets here and parentheses here. You've got to start with this one that's in the very middle and then work your way out. So we are starting with this 10 divided by 2. That's going to give me 5. So now drop down everything else. I'm going to kind of scribble this out. We've used it. Drop down everything else we haven't used yet. So I've got bracket minus 7 times 3. On the other side, we've got the minus, the 3 squared, close your bracket, plus a 4 cubed. Okay, I'm still not done with parentheses since I have a bracket. So within this bracket, now use your order of operations. I've got an exponent in the bracket. So 3 squared means 3 is your base, repeating 2 times. So you've got 3 times 3. 3 times 3 is 9. So let's drop down everything else we haven't used. We got minus 5, close your brackets, minus 7 times 3. Close your bracket this way, plus a 4 cubed. Still not done with those parentheses because my bracket's not completely solved for. So now we need to do 9 minus 5 to give me 4. Now I can drop down everything else. And now we are done with parentheses. So exponents. Do we have any exponents in this problem? Yes, we do. We've got 4 cubed. So 4 cubed means your base is 4 and it's repeating 3 different times. So this is 4 times 4 times 4. 4 times 4 is 16. Drop down your times 4. And if you don't know 16 times 4, 6 times 4 is 24. So you write your 4, carry your 2. 1 times 4 is 4, plus the 2 is 6. So drop down everything else, plus 4 minus 7 times 3. So that is my exponents. So now multiply and divide. I can multiply right here. So we get 64 plus 4 minus 21. 7 times 3 is 21. And now we need to add and subtract. And we're adding and subtracting from left to right. So it does not mean we always add first, then subtract. You're going from the leftmost to the rightmost. Well, it does happen that your addition is first in this one. But I just want to make a point. That's not always the case. So 64 plus 4 gives me 68. I'm going to bring this up here. We've got 68 minus 21. So this is my last operation. So 68 minus 21, 8 minus 1 is 7, 6 minus 2 is 4. So we get 47. All right, and then our last one. So with this, you need to simplify the top, then completely simplify the bottom, and then you can use that fraction bar to divide. Okay, so if I'm just focusing on this top portion of this fraction, we have, please excuse my dear Aunt Sally. in this top portion of this fraction, we have some parentheses. So in those parentheses, we've got exponents. So 3 squared, I'm going to kind of running out of room here. So 3 squared is the same as 3 times 3. So that is 9. So we've got 7 minus 2 in parentheses 3 plus 9. Okay, I did this right here first. All over. And I'm going to kind of just leave this blank for a second. We're going to just focus on the top, then I'm just going to focus on the bottom. Okay. So then on the top, I'm still not done with parentheses. So 3 plus 9 is going to give me 12. So now I've got 7 minus 2 times 12. So now in the top of this, we need to multiply first. So 2 times 12, we're going to get 7 minus 24. And I picked a bad example because we have technically not gone over integer rules. So I apologize for that. So just kind of, I guess, trust me when I say 7 minus 24 is negative 17. Okay. Okay. So I've simplified the top of this fraction to just that one number. So now let's go back and focus on the bottom of that fraction. So in the bottom of that fraction, we've got parentheses. So we need to use these parentheses first. So you've got 2 minus 1 to give us 1. So that means I've got 5 times 1. The only operation we have left is that 5 times 1. So that's just 5. So since this is fully simplified at this point, it just needs to kind of carry along with this. So this would have been all over 5, and now this is all over 5. 5 does not evenly go into 17, and so this is my final answer right here. Okay, and I apologize for this negative and for that being an ugly, I was about to say unpretty, but an ugly final answer. So if I kind of lost you on this last step to this one, don't worry about it. You won't have one exactly like that, as long as you kind of understand the process that went through on solving that one. So that is all I have for this lesson. Let me know if you have any questions, and of course, pause it and rewind this video as you need it.